Hey everybody, so let's solve the first problem in the test exam, 4.8 from homework 4. Let's get right into it. So this is the circuit from the problem. We have the 180 volt source on the left with a 5 amp source on the right in another branch. We have a 12 and 5 ohm resistors in series, and then there's another branch in the middle that has a 2 ohm resistor, and we're trying to find the voltage across that resistor with polarity negative on the bottom, positive on the top. And we've been asked to find it using the node voltage method as opposed to the mesh current method. Great, so let's assign some things on the circuit here. I've assigned ground to this bottom node here, so that means that the voltage on the bottom side of this source is 0. Ground, of course, is at 0, so we know that on the other side of this source, the voltage is 180, because that's the change here from the source. And we know that the node up here, we can just label it V0, because the voltage across the 2 ohm resistor goes from ground to V0 above ground. V0 above ground is V0. So V0 is our node up there. Beautiful. So for the node voltage method, we're going to make use of the Kirchhoff's current law, which you may remember says the sum of all currents into a node, that's a node, it's an arrow into it, must equal the sum of all currents flowing out of the node. That is to say, there can be no like gathering up, accumulating of current in a node. The current that comes in must go out. And the way that I usually like to do these is to label all of the currents going out. So we have 3 currents going out to the left, out to the right, and out downward. So what we're left with here is 0 currents coming in, and the sum of our currents going out. So let's figure out what are these different currents. Let's label these maybe. Let's label this guy I1. On the right, we'll label it I2. And the bottom here, we'll label that I3. So let's set up this equation. Well, what is I1? Well, we know that V equals IR, right? This is the relationship between voltage drop, current, and the resistance through which the current runs to drop the voltage. Or the voltage drop occurs as a result of the current pushing through the resistance. This is the relationship. So for this current I1, as it travels from V0 down, wow. Okay. So we're going to use V equals IR to find the current through this branch going out of the node. V equals IR, so I equals V over R. The V we're talking about is from our node voltage to the next voltage. It's not ground because we have this source in between. So the change in voltage from our node voltage to the 180 is simply our node voltage minus 180. So V0 minus 180. And we're going to divide that by the resistance. So these are in series, so we can just add them. So it's V0 minus 180 over 17. I2 is going out, and it's just our current source, it's 5 amps. And I3, using the I equals V over R, well, V is V0 minus 0, so it's just V0. And the resistance in this branch is 2 ohms, so we simply have V0 over 2 ohms. All right, so those were all going out. And everything going out must equal everything going in. So if we sum these up, then we have I1 plus I2 plus I3 equals everything going in, which is 0. Okay. All right. So now let's sum these up and find V naught. You'll notice that we only have one variable here, right? V naught. And so as we add these up, we'll be able to simply solve the equation and get the right answer. So I'm going to erase this and rewrite it. Okay, so we have the equation rewritten here. This is I1, this is I2, this is I3. V naught minus 180 over 17 plus 5 plus V naught over 2 ohms equals 0. Now there are lots of ways you can solve for these. I like to factor out a V naught. So group all the V naught factors together. The way we do that is we separate out this fraction first. So V naught over 17 minus 180 over 17 plus 5 plus V naught over 2 equals 0. So now we have this factor of V naught and this factor of V naught. If we factor out a V naught from them, then we get V naught times 1 over 17 plus 1/2 is equal to, or before we actually do that, let's say minus 180 over 17 plus 5 equals 0. Now we're going to add these third and fourth term over to the right side and divide by the coefficient of V naught. So again, V naught is equal to, flip the signs here, so we have 180 over 17 minus 5. All of that divided by 1/17 plus 1/2. Now you can get some least common denominators and do all the fraction stuff there, or you can just plug this into a calculator and you'll end up with 10 volts. So that's the final answer. 10 volts of V naught equals 10 volts. And we did that using the node voltage method, Kirchhoff's current law. Hope that made sense.